Hello, today we're going to look at 7.3 volume, but we're going to focus on what's called the shell method. So there's going to be some cases where the disc or washer method, it doesn't work, all right? So let's just suppose we have the equation y equals the quantity x minus 1 times x minus 3 squared, and we're rotating it about the y-axis. So if we were to just kind of draw some things in, right? We know using the disc or washer, it's big R minus little, or big R squared minus little r squared, and it's all the addition of these little discs, right? Or washers in this case, okay? But what we notice is if we do that, because remember, our radius has to be perpendicular to our axis of revolution, or our rectangles do. Okay, so that would mean they'd have to be in terms of y. Well, that would also mean we have to solve this equation, x equals something in terms of y, and that's not necessarily easy to do. So if we can't easily solve for a specific variable, in this case we would need to solve for x in terms of y, we have another method. It's called the shell method. So this is where our rectangles are going to be parallel to the axis of revolution versus our rectangles being perpendicular with the disc or washer method. Okay? Now, if we have a horizontal axis of revolution, our volume is going to be in terms of y. Okay, so that's talking about the axis of revolution. If it's a vertical axis of revolution, our volume is going to be in terms of x. But let's just talk about how we get those equations or what these really represent. So it's called the shell method because this time what we're doing is we are taking these rectangles, and if this is our radius, as we're revolving around our axis of revolution, we're getting these big cylinders, right? But what part of these big cylinders are we getting? We're just getting the outside portion, okay? So we're getting this part. Forget about the tops of these cylinders, and that's called our surface area, right? So our surface area, really, to get the equation of the volume using the surface area, we have to recognize that surface area or volume is equal to the surface area times our thickness. Okay, now if we have a horizontal axis of revolution like we do in this picture, then what we have is volume is equal to 2 pi RH because it represents the surface area times our thickness. So again, we focus on this rectangle here, okay? This is going to be parallel to our axis of revolution. So this is in terms of delta y. That's our thickness, okay? Our height, okay, the height of this cylinder is going to be in terms of our y value, okay? So it's the height in terms of y. Our radius is also going to be in terms of y. So our radius is this guy right here, and that's going to be in terms of y as well, because as we're moving around, our radius is changing, but what is our distance of our radius? It's just in that y direction, okay? So you'll see what I mean when we go through some examples. So that delta V is 2 pi RH delta Y. Looking at it in terms of an integral, we have 2 pi times the integral from C to D of our radius times our height times our dy. Well, our radius is our y value. Our height is that function in terms of y, okay? And remember, 2 pi RH is simply our surface area of a cylinder. Now, if we're looking at a vertical axis of revolution, and then again, we draw our rectangles are going to be parallel to this axis of revolution. So that's going to be dx is or delta x is our thickness, okay? The height is going to be in terms of x, and our radius will also be in terms of x, will be in terms of x. okay? Now, when we're looking at that formula, the volume is surface area times the thickness, because this is getting rotated around and we're adding up all the surface area pieces. It's going to be 2 pi times the integral from a to b of our radius times our height, dx. So our radius is going to be that x. In this case, it's the x value, because wherever I move my rectangle, my radius is from that x value to our axis of revolution. And then f of x dx. Let's look at some examples of setting all of this up. Okay, so let's go back to that first example that we talked about, and we tried to use the disk method, but it was not easy to solve for x in terms of y. So what do? Well, if we rotated about that y-axis, so here's our axis of revolution, it's going to be easier to use the shell method. So I draw in my rectangle, that's this green here, okay? And so the rectangle is always going to be parallel to our axis of revolution. My radius is perpendicular to that axis of revolution. Now, to determine if it's in terms of x or in terms of y, we look at the thickness of our rectangle, and that represents delta x, or dx. So that means our height needs to be in terms of x, and our radius needs to be in terms of x. Now, keep in mind, these rectangles are moving, right? Depending on where we are, these rectangles are moving, and so that's going to change our radius. So as we're gathering our information, to figure out what our radius is, it's always the right minus the left when we're talking about a horizontal radius, okay? In this case, it's our x value, wherever we are on our function, minus our axis of revolution when it's right minus left. So it's x minus 0, or our radius in terms of x is just x. Our height is going to be this function here, okay? And it's going to be in terms of x, so it's simply this equation here. It's our y value, because that's our height. Our height is this y, but y we need in terms of x, so that's our green here. So then, using the shell method, setting up our integral, we're 2 pi times the integral from a to b. Well, in this case, it's 1 to 3, okay, of our radius times our height. And so you could throw this onto your calculator just as practice, and you should get that this integral here is 12/5, and then multiplying it by 2 pi is where we get the exact volume from. Let's take a look at this next example. I want to see if you can set it up before we dive into it. So this second example says find the volume generated by rotating the area formed by these two equations and x equals 0 about the line y equals -1. So the first thing I want you to do is draw your diagram, label it, your height, your radius, your thickness. Come back and check in a second when you're done. Okay, so our axis of revolution is y equals -1. So that means my rectangle is going to be parallel to it, and the thickness is going to be delta y, or dy. Okay, my radius is perpendicular to the axis of revolution, and since my thickness of my rectangle is dy, my radius is going to be in terms of y. Okay, and our height of our cylinder is going to be this function in terms of y. So as we're rotating it about, you'll see we're going to get something like this as we rotate around. And we're going to add up all of this entire shell, okay, just the surface area. So as we go through, now see if you can set up your integral, okay? Now hopefully you recognized that we needed these two equations in terms of y. So we had to solve for x in terms of y. So I just labeled them. Red is this guy here, and the blue is the bottom one there of y equals x squared. So solving each in terms of y, we get these two equations. x equals y to the 3/2, and x equals plus or minus root y. All right, so if we're looking at our radius, okay, now our radius is vertical, so it's going to be top minus bottom. So it's whatever this y distance is minus the axis of revolution. So it's y minus -1, which becomes y plus 1. The height, all right, is again going to be in terms of y. So since the height of this cylinder is horizontal, it's going to be right minus left. So the right is that blue, which is the square root of y, the positive part of it, minus the red, which is y to the 3/2. So setting up the integral, we have 2 pi times the integral from 0 to 1, because those are the y values of our bounded region, times our radius, y plus 1, times the height, which is y to the 1/2 minus y to the 3/2, and then dy. So if you throw this onto your calculator, verify that you end up getting approximately 2.3935957. Now, if this were on the AP exam, we would cut it off after 3 decimals. So you could say 2.393, or they accept 2.394 rounding up. Either one is accepted. Okay, this last example, I want you to set up the integral and use your calculator to find the volume of the solid generated by x squared plus y squared equals 1, and it's revolved around the line y equals 3. I want you to use shells, okay? So go ahead, draw your diagram, and check back in a second. I'll show you what we should have before you set up your integral. Okay, so we should have a circle centered at 0, 0 with a radius of 1. So that's this blue guy here. Our axis of revolution is y equals 3. So that means I needed to draw horizontal rectangles parallel to our axis of revolution. That means our thickness is delta y. So that means everything needs to be in terms of y. Okay, the height of our cylinder is going to be in terms of y, and the radius is going to be in terms of y. Okay, and then as we rotate it, we'll rotate it and it'll look something. As we rotate it about that axis, we're going to have this cylinder looking thing here. Okay, see if you can figure out what your radius is and what your height is in terms of y, and then set up your integral from there. Check back when you're done. Okay, so our radius is a vertical radius, so top minus bottom. So it's the axis of revolution minus that y value, because our radius is just in terms of y. The height, all right, so we needed to solve for x in terms of y. Okay, now since we had a circle, instead of worrying about the plus or minus, we know that 1/2 is the same as the other, so we could just say x is equal to 2 times the square root of 1 minus y squared. So that would be the height of this cylinder here. So now to figure out the volume, it's simply 2 pi times the integral. We're going from -1 to +1, because this is -1, 0, -1. And this point up top is the point 0, +1. All right? So as we go through, we take our radius then, times the height of that cylinder, times delta y. Now if you were to throw this on and eventually evaluate, you would get an exact answer of 6 pi squared, or approximately 59.218. Now, if you'd like, we will do this last example 4 in class next time we see each other, but go ahead and give it a try. This kind of compares the shell method to the disc or washer method that we learned last time. So give it a try and see how you do, and then we'll compare it when we see each other in class next time.